Hi, welcome to the G Research Open Source Software Podcast, the GR-OSS OUT podcast. I'm your host, Jay Faulkner. This is episode 5, and I really just want to thank those of you at home, at work, just listening or watching this. We put this together for y'all and to spread the good news about what G Research is doing in the open source world. And that's something that I'm really passionate about, and I hope you are too. And our guest today is someone I've been hoping to speak to for a long time, really not even for the podcast, just in general, because I find the work kind of interesting, or at least it's a topic I don't know a lot about. So our guest is Florian Verdonck. Why don't you tell us a little bit about yourself? You know, maybe if you've got a handle on GitHub or something people would know you by, and what you do in open source, how you got involved with us.
Hi folks, my name's Florian. I live in Belgium and I've been doing open source work for the last 7 years. My open source journey started with a project called Phantomus. Phantomus is a code formatter for the F# language. And when I initially started that project, it was a bit of a rough stage. I ended up becoming, core contributor and then transitioned to a maintainer. But there was only so much I could do and, the spare time I had for it. And at some point, I reached out to the folks of G Research who are interested to give back to the community, specifically to the F# community. And I proposed that if I could have a little bit of more resources, I could bring Phantomus to that next level, and they would be able to use it in-house. And that's actually how I joined the open source team years ago. It was little contracts, little side gig, and from one thing came the other. There was a hunger for a little bit more F# development, and I was going in the F# direction pretty hard. And then from one thing came another, and I eventually joined the open source team full time. And for the past 2 years, I've been working on F# and some other stuff as well. So very excited to be here.
Oh, well, that's really neat. Now, I'm kind of an operator turned developer. I've really only worked heavily in Python, although I have written a little bit of C#, so at least I know something about that ecosystem. But can you maybe help our listeners understand why you would use F#, or maybe how F# is different from other languages? And honestly, even just for me, maybe even give me an overview of why you want to do functional programming instead of object-oriented. Like, just what's the lay of the land for F#?
Gotcha. So F# is like the younger sibling of C#. It's not like brand new. It was initially created around, I would say, 2005. And it tries to be the OCaml or the Haskell of .NET. So it uses the same .NET runtime, but it embraces functional programming. Now, taking a step back, functional programming is a style of programming where you would build software by composing pure functions and avoiding a shared state. And you would do that with immutable data. So it's more about treating computation as the evaluation of mathematical functions, so to speak. So functions are a first-class citizen. You can pass them around, but at its core, functional programming really is about you're focusing on what do you want to solve versus how you would solve it. Like in object-oriented or procedural programming, you would explain to the computer what needs to be done. You would describe like step-for-step instructions what needs to happen. While in functional programming, you're more going to describe what transformation your data needs to undergo to solve a certain problem. So the key difference, I would say, is like state and immutability. So in functional programming, you really separate the two. You would have your data structures, which just purely contain data. So there's no like encapsulation and behavior attached to them. And you would have functions, which in a good way, you would try and go for pure functions, which take an input, produce an output. And if you pass in the same input, you get the exact same output. That's one of the key things. And when you have these pure functions, you can actually excel at concurrency and parallelism because all these things can be executed in parallel because you don't have that shared state. And that's sort of in mindset or in thinking when it comes to functional programming. So pure functions, immutability, and the focus on more transformation.
So is there an example of like, I understand a little bit, like honestly, as an object-oriented programmer, it sounds kind of frightening. It sounds like losing a lot of the helpers you get. So like I imagine there has to be problem sets that maybe that approach is well suited to. Is that maybe a good way of looking at it?
Yes and no. Actually, I think functional programming can really be applied in a broad sense, and it just is not what a lot of people new to the industry are confronted with. So it's just foreign because most people learn object-oriented first, and then there's a little bit of a mind shift. But you really need to focus on the transformation because that's typically what a lot of systems do. For example, a web server, there's a request coming in, and there's a response going out, and then stuff happens in between. So that's where functional programming can really shine. Or the same with like data transformation in whatever, data sources you have that needs massaging. You just really pass it from a function to the next function to another next function, and then sort of compose a functional pipeline to really deal with that transformation without really having to, give that to like an object and then have that state of the object change over time.
So it seems like maybe if you're reading a functional code base, you can make better assumptions about it. Whereas in Python, I might have to worry about if I'm passing an object into something, things set on that object might change the behavior of the function some. But in functional programming, it sounds like it's much more intended to be you pass in a static set of things and you get a static set of things back.
Yeah, correctly. So it's a little bit easier to reason about because, everything is typically immutable. So you don't have to keep track of who could change that variable over time. That's just not possible. That it just came in and you transform it and it goes out.
So you mentioned that there's like OCaml, there's Haskell. I guess always traditionally I think about Lisp as an old school Linux guy when I think about functional programming. Why F sharp? Like what does F sharp have that maybe these other languages don't, or is it just a chocolate versus vanilla thing? Why F sharp?
So F sharp was heavily inspired by OCaml, and also I guess has definitely similar story beats in Haskell. But the nice thing about F sharp is that it's not always as strict. Like you can do object-oriented things in F sharp, so you're able to do object object-based programming. And the hook for me is that F sharp runs on the .NET runtime. And I originally was a C# developer, so that's how I kind of rolled into F sharp. I wanted to do something functional programming like, and because F sharp isn't, it's very practical as well. So it's not really academic. There's not a bunch of theory or category theory that you need to know up front to really get started with it. And so that's where it's a very beginner-friendly entry point.
I think it might shock some people listening to the podcast here that we're talking about .NET on an open source podcast, because a lot of us remember the early days of the .NET framework and things like that. So, I mean, is it safe to assume that most of the work that's happening in that ecosystem today is happening on those core open source runtimes, or is the relationship more complex than that?
So I'd say it's a little different than with other programming languages, as in it is open source, but Microsoft, just keeps a good grip on everything and still determines when things ship and then when not. But in the case of F sharp, it's actually been one of the pioneers of open source in .NET. F sharp as a language was a lot sooner open source versus when .NET became cross-platform and open source. So in many ways, F sharp really pioneers certain ideas for the broader .NET ecosystem or for the language of C#.
Yeah, I actually appreciate the approach of .NET a lot because it seems like they try to have that basic set of functionality and then they kind of expose it to you. They come to you, right? They come to your place. You can use F sharp, which is a more functional flavor. You can use C sharp, which looks a little more like a C++. It's object oriented and stuff, or even like Visual Basic .NET. Like people don't always love talking about Visual Basic, but I know a huge number of people coming from the DevOps world who learned programming through Visual Basic and then were excited to learn that they could turn that Visual Basic or even PowerShell use of .NET and carry that over into C sharp and F sharp. So that's well, probably not so much F sharp. You're maybe one of the first people I met to use F sharp. So that kind of leads into my next question. Is it that like F sharp is maybe a niche project, or is it more that it occupies specific use cases that maybe I've not interacted with?
So I think it's a little bit more niche in the sense that most companies wouldn't consider it because it's really is the little sibling, little brother of C sharp, and there's a lot of overlap where you might just get the job done with C sharp and also do some functional programming. Like F sharp is a lot more elegant, but historically they've just never been on the same level, and the user base of F sharp is a lot smaller. So to that extent, it's in this weird spot where it needs to compete a little bit with the C sharp audience in terms of the .NET bubble, but it's also having a lot of parallels to what people do with TypeScript, what people do with Python. So there's that audience there as well. So in that regard, it's just like in a bit of a difficult spot that it just has inspiration from most places or inspires a lot of other languages that it's just not heavily considered by most companies, I guess.
Okay, makes sense. So let's zoom in a little bit, right? We've been talking about F sharp in general to kind of lay the background, but you were talking about Phantomos and how it's a code formatter. Can you maybe talk about the history of that? Because I know that they're kind of a hotter thing right now, right? But I'm curious, how long ago did this start? Like, what was the basis of Phantomos and the approach to it?
So the interesting thing about Phantomos is that I didn't create it myself. It was a community project. It was done as an internship, actually, where they tried to use the F-sharp lexer and parser, which are parts of the compiler, and then instead of going to the binary output, which then runs on the .NET runtime, they just go back and try and reproduce source code again. And it uses an internal representation of the compiler, but then it can go back to source code and format things in a very consistent way. In other languages, this works really well, and it has a large appeal because it solves a problem you could have in your team where multiple people have like different preferences on style and can a little bit bigger about that. And at the end of the day, you just want to get over with it, format the code. It looks as if any developer would have written it because that's the agreed set of rules that are implemented. And then from that point of view, if all the code is constantly formatted with a formatter, your source control, like your Git diff, will be a lot better because you're constantly, if you touch something that was unrelated, the formatter will strip it and give you like the best diff when going to source control. So that's definitely one of its strengths. And when I was starting with F sharp was my first language which was indentation based. So I was using curly braces, and it all matters a little less. You do the curly braces, you do the semicolon, but because F sharp is indentation based, it often was a little bit tricky to know why invalid syntax wasn't okay, or when you did have valid syntax, like how can I make this prettier? So I basically just yearned for a formatter myself, so I was scratching my own itch, and I, found the Phantomos project. It was already doing what I was hoping it does, and we started improving that bit by bit.
I had no idea that F sharp was kind of a white space based language as well. It's almost a rite of passage for a Python developer to troubleshoot the missing indent or the spaces when you should have used tabs, which nowadays will actually raise an error in Python. If it parses the file and it has both spaces and tabs in it, it'll just immediately throw an error to prevent people from falling into that particular hole. But I know with Python in particular, part of the difficulty in getting code formatter adoption is that everyone kind of has their own idea about how code should be formatted, which kind of envious of Go. They had Go format from the beginning, so there's almost like a prescribed style that comes with the language definition. With F sharp and Phantomos, was there already this is the proper style, or did sort of bike shedding about the style or the knobs you have in Phantomos to adjust the style part of the work of getting it done?
That was definitely one of the trickier areas. So the formatter was late into the game. Like when you see certain new languages pop up, what they would typically have these days is just a formatter built in, and there's only one way to do it. Like that's really the sweet spot. It's one of the things Gleam, another functional programming language, rather new. They just got that right from the start. There's one way to write a Gleam program. And F Sharp is a little different that most people don't pick F Sharp as their first language. So depending on where you're coming from, you'll have a certain preference in code style. When I started the Phantomus project, there was some outline of how it should be done, but that's really what the original creator of Phantomus had envisioned. So that was very nice, but when you want to revisit that, it was a little bit tricky because some user would submit an issue, hey, what if we do it this way? And then you can go along, implement that. Somebody else comes like, yeah, but I don't really agree with that. Shouldn't that and that be better? Or, sort of change how that is. And it's such a subjective area. And at a certain point, I had enough of it. I was like, come on, guys, but we should have some consensus here. And that's where I sort of pushed for the official Microsoft F Sharp documentation to have a style guide. Oh. And that became a community initiative that there was like a review process, but everybody can just send pull requests to that style guide. And if the style guide changes, the defaults of Phantomus would change. That's sort of the rule of thumb.
Yeah, and so for anyone listening, I'll make sure that link and links to Phantomus end up in the YouTube description if you're looking on YouTube, or the podcast description if you're listening on audio, so that you can go check that stuff out, because that sounds great. That's I think that's a side of open source that a lot of people don't really realize. It's easy to see the code piece, but I'm sure that a huge difference is made in the F Sharp community by doing that lobbying of Microsoft, by working together and getting that spec published. So that's really impressive. And in a lot of ways, I wish Python would do the same thing, just as long as the spec they come up with agrees with my thoughts on how Python should be formatted, of course. So that sounds really neat. Is Phantomus primarily what you've worked on with F Sharp? Has there been any other projects or ventures around in F Sharp that you've worked on in the last few years?
Well, Phantomus has been the starting point, and eventually I tried to do some upstream contributions to the compiler itself, because the parser was not giving us. So the parser creates an abstract syntax tree, which is a representation in code, tree structure of what code is in the file. And that didn't always have the exact information we were after to really create text again of like the format result. So my first contributions to a bit larger things in F Sharp was the compiler, trying to get some more results in the parser and lexer. And that eventually brought me closer and closer to the other phases of the compiler, and to type checking, and eventually to editor tooling. So have some pull requests that landed in IDEs like VS Code or JetBrains Writer. And I also took an interest in something called Fable. That's another compiler for F Sharp, where you can compile F Sharp, transpile F Sharp to JavaScript. And that's also in a very interesting world and a little bubble within the F Sharp ecosystem.
So that's kind of, I'm asking questions out of ignorance here a little bit, because I'm curious about it. Like, when you have languages, like you have this, F Sharp, you have C Sharp, you have kind of all these things that work together, how much of that compiler is F Sharp specific versus how much of it is sort of interfacing to the .NET code? What is that sort of shaped like across the ecosystem?
So the F Sharp compiler really is its own thing. The C Sharp compiler is based on something called Roslyn, and F Sharp just never went in that direction or used the same building blocks as C Sharp. But at the end of the day, both produce the same bytecode that will run on the .NET runtime.
Isn't Roslyn the old school Microsoft C compiler? Like, that name sounds super familiar. So is that actually the original Microsoft compiler they use for the C++ stuff as well, or am I just mixing up memories here?
I think you have that mixed up. As far as I can recall, Roslyn would be the latest and greatest of the C Sharp compiler.
Okay, yeah, trying to connect the dots here, and sometimes they aren't there to connect. So, I know that lately we've sort of been shifting focus away from F sharp, sort of putting a bow on our work there. So I'm curious about what's currently your day to day, and maybe what are you looking to be working on in the future.
So the interesting thing about being a part of the open source team at GR-OSS is we contribute to a lot of things because we use a lot of things. And during the well, starting in April and Easter going forward, I started contributing to a project called MLflow, which I can tell that rings a bell. And the interesting thing we're going to try and do, so MLflow has this thing called an experiment train, which is like a web server that captures everything that happens in the machine learning part of things. And well, it doesn't scale to the volumes of data that your research is trying to flush through it. So we are trying to rewrite some parts of that MLflow Python code base in Go, just because, well, doing a bit of a rewrite in Go. And that's one of the other projects I'm working on this year.
Yeah, and if folks want to learn more about MLflow, we had an interview with Jonathan Gianuzzi about Fast Track ML, MLflow, and sort of that suite of tools that G-Research works on. So if you want more information about that, I'll make sure that we have that episode linked in the description for you to dig in there. But so one of the things we always like to talk about at this podcast, it's sort of an important thing to, we call this podcast Gross Out, not just because it's the acronym, but because, when you've been working in open source a long time, you know that there aren't clean cuts. You know that it's not always a straight path from A to B, that there are struggles to get there that we have to overcome. And so I'm wondering if you have sort of a gross story of something that you encountered in open source that you had to attack and get over to achieve your goal.
That's an interesting question because, well, in open source, there actually are a lot of horror stories. We typically, when we do these kind of things, we bring a feel-good story and we're all trying to improve the world and whatnot. But, there's a lot of bad things as well. But I guess if I had to pick something that I kind of want to touch here would be that we don't talk enough to each other, like in general. When we contribute to projects, I just see it so often that people will create a fork and never, talk to the original maintainers like, hey, can we reconcile the differences here, or can we get back to one happy code base and then to be one wonderful community? And it just sometimes is also very hard when contributing to somebody else's project. You raise that pull request, you really put your best effort in it, and then you get no reaction at all. Like that can be right in field sometime. So I think that's what's one thing that can be really difficult about this job / really stressful. That why on earth am I not getting a reply? Why on earth did person X do PRY or fork or whatnot? And it's really, this would be so much easier if a lot more people just talked more to each other via call like we're doing right here, right now.
There definitely is a little bit of aspect of open source where sometimes, especially if you're contributing to a project or a small project for the first time, where it feels like you're just screaming into the void and you're hoping that something talks back to you. And I'll say for me, some of the moments when I felt the worst in open source is when I've looked at a project that I care a lot about and I've seen that something fell through the cracks and that someone else had to go through that because of me. And that's maybe a reminder that when those moments happen, it's not something where a person is trying to ignore your code or where they don't want you to succeed. It's all of us have so much work to do, have so many things vying for our attention. And that's even, Florian and I are kind of lucky in that we get to spend almost all of our time working on open source software, promoting open source software. And when you interact with a project that might be someone's weekend project, or they're stealing time from their manager to get it done, so I always try to bring a little bit of empathy to those gross situations. But it's tough when you're going through the valley of waiting for someone to respond to your PR. And so, like, if you're listening to this podcast, I would say, if you're just getting started on open source, reach out to someone. Find if a project has a chat channel, a Slack, a Discord, an IRC channel, a mailing list. Just reach out and have a conversation with someone about what you're trying to do. Because almost certainly, and this is the non-gross thing about open source, you're never the first person to have a problem. You might be the first person who comes with time to solve the problem or with an idea to solve the problem, but you're probably treading ground that other people have before. So I'm really glad that you touched on that, because I definitely think there's a feeling where that may be someone's first step into open source is throwing a PR into the void and hoping that someone responds. And that is definitely nerve-wracking, even when you've been doing this for years and years and years, much less when it's your first time through. So I really appreciate and enjoy that story. So I do want to really thank you for being our guest. I've learned a lot about F#. I'm going to go look at some F# code now, since maybe it'll scare me less if it doesn't have the parentheses and all that we're scared of from Lisp. I'm a Python developer. I've got to run from brackets. So I really appreciate that. I want to thank you for being the guest. I want to thank everyone who's listening here today. We're going to make sure at the end of the video to link some of our content that's on this channel. I don't know if we have any F# videos, or Fantomas. Do you have any of those talks on this channel, perhaps, Florian?
Not on this channel, but there are some videos about how you contribute to Fantomas, which I made a while ago, and it's really interesting to, it's not only about the code, it's also about trying to engage other people to join in and join the effort. So I have some material there.
Absolutely. So we'll make sure that there's a link to that video here. There'll be a link for you to subscribe to the podcast as well, or subscribe to the channel. If you're listening on your podcast app at home, please go ahead, give us a rating. I hope it's 5 stars, but be honest. Comment, like, subscribe. But for now, I'd like to thank you for listening. This is the G-Research Open Source Software Outreach Podcast, the Gross Out Podcast. I'm Jay Faulkner, and on behalf of Florian, I'd like to thank you for your time today, and I hope you have a pleasant day. Bye-bye.